Hello friends, welcome back to compiler hacking. In this video, I thought I'd work on a little bug I ran across. I was trying to do something with symbols and I thought, well, I'll just create a range of characters A through Z and then I'll print them out as symbols and do something with them. But when I did that, I noticed it didn't work right. So if I run this through Ruby, you can see that's what we expect. But if I run this through Natalie, then what we get is something completely different. It's a whole bunch of stuff. It just keeps going. It shot past the end of Z, and then it did AA and so on and so forth. It did not get to ZZ. It got to YZ, and I suspect we're doing some sort of alphabetic comparison versus a lexicographical comparison. I'm not very good with terminology, but something like that. So I think that we'll go write some tests and see some failing tests and then write the code to fix them and just do the standard test-driven development kind of thing to fix a bug. So hang out with me and we'll see how it goes. So let's do a string test to start. And I think should we test suck? The suck method returns the successive character or string. Actually, there shouldn't be a problem with that. Let's go look at range value. So the way that works is it does a comparison, either a less than or equal, depending on if it's a 1.10 or 1.10, so on. Something like that. If there's 3 dots, then we exclude the 10, and what you get would be 1 through 9. So that's why that is there, which changes the comparison. So I'm thinking that we want to test less than, which we don't have. I'm a little surprised we don't have less than. Do we even have... oh, we have the shuttle operator. Okay. But we don't have less than. Fun times. So here, let's just see. It, I don't know, turns true if left-hand side is alphabetically less than right-hand side. So A should definitely be less than B. Should equal true. A should not be less than A. False. Let's just run those through Ruby to make sure that that passes absolutely. And then what about Z less than AA? So Z is not less than AA, but and that makes sense because when we're comparing strings, we're doing it alphabetically. So like if you had a file listing, you would want this one to come first before Z. But in terms of a range comparison, when we're doing A through Z, that I think is different. Fascinating. What if I had Z .AA? What happens? Well, let's just consult Ruby and that's not it. If I have Z .AA, nope. Okay. Z AA 2A is empty. Fascinating. All those are passing. Great. We'll make sure they all pass in Natalie as well, which I assume they do. I don't think the problem is here. No, the problem is not there. The problem, well, you know what? Let's just do the equal sign as well. This one's going to be true. Oh, hi. Just in editing here, and I noticed that I made a little mistake. I forgot to add the equal signs on these other ones as well, so I'm just going to do that and run Ruby test and bin Natalie string test just to make sure that everything's on the up and up. I didn't want to leave that in the video because people would comment. I actually did discover it. Fix comparison in test. Okay, well, back to the program. Good. Okay, so add test, add some tests for string comparison. Okay, so that was fine. There's not a problem there. So let's go to range test and let's go to 2A and say it should it handles strings. It handles strings. Come on. R is A through Z. R2A should equal AB. Just make sure that passes. This one should fail. Yes. So that is what we were witnessing. It just blows past the end and keeps going all the way till YZ. So I suspect there's a problem with my logic here. So let's go ahead and do, so I was noticing that 2A and each have identical implementations, with the exception of this adds it to an array. That is different. This one, and then here it is again, the same implementation. So we have this same implementation 3 times. So we should add these tests 3 times. We'll do this here, and we'll just make a little lambda array item. Here's an empty array. Nope, that's the range. Each item, append it to the array, and then return the array. So now we can do array call on range should equal that. So now we should have 2 failing tests. Yep. And last is the triple equals, it handles strings. Returns true if the range contains the given string. So R B, sure, I'll do A, should equal true. AA should equal false. Now we should have 3 failing tests, I believe. Very good. And with Ruby, we should have no failing tests. No, line 177. Okay, that's weird. So you're saying if I have A through Z, and I do triple equals with AA, it's true? I thought it was equivalent to include, but it's not. Is that a bug? Did I find a bug in Ruby? Or why would that ever be true? Fascinating. So I don't know why that is true. Why is that true? In my mind, what that meant was kind of behind the scenes turn that into an array and say, does that array contain this item? But that's not what Ruby's doing. Ruby is doing something else. That is counterintuitive. And when I run into counterintuitive things in Ruby, I'm a little bit shocked because almost everything is intuitive, I think. I've been using this language a long time. Why? It's doing an alphabetical comparison just between the first item and the last. So we know that A is less than YZ, of course. And YZ is less than Z. So all it's doing for this is comparing the beginning and the end. And very good. We'll do the same thing. True. If the range, so this, even this language, if the given string is between the first and last item of the range. I mean, that's really what it's doing, I suppose. So all the tests pass there. Well, the funny thing about that is that now we're only going to have 2 failing tests because our implementation does this perfectly. Not in the same way, of course, but we will fix that. Let's go ahead and start with that one because that's like really top of my mind right now. So we're going to say if begin is greater than or equal to, no, not begin, arg. If arg is greater than or equal to begin, and arg is less than or equal to end, then return true. But this is only if we don't exclude the end. So we'll do it like this. And it's not return true, it's return true value. True value the. And this one's going to be very similar, except it's going to be less than here. Thank you for reformatting that for me. And let's make sure that test still passes. Should still have 2 failing tests if I did everything right. And looks like I did. I'm going to add everything to the index. That's fascinating. It really is. Makes me wonder if I even need this special optimized version for integers, but I'm not going to touch that right now. So let's go up to here and do the each. Let's do the each case, which is right here. So I suspect we don't want to be doing equals, or sorry, we don't want to be doing less than. We only want to be doing a comparison of equals. And I think we want 2 cases, just like we did down here, where we do if exclude end, then do something. I'm going to move this down a little bit. Otherwise, do this other thing. And we do need this, and we do need that. Actually, I'm just going to need all of that. I'm just going to need it all. Don't need that, though. So I think we're going to do something like this here, and then here as well. But things have changed. This is going to be equal sign. As long as it's not equal, we're going to keep going. And as soon as it is equal, then we're going to do something different. So if we ever get there, but what if, okay, we're needing a special case. I'm going to put a to here. Special, let's do abort if left-hand side is greater than right-hand side. Actually, begin and end. I don't want to forget that because I just had that thought. Because if you start with a higher value on the left and you, if we're only doing equals comparison, then you're never going to get there. It's just going to keep going forever and ever. So I think if we are excluding the end, then we can say if it's not equal, then keep going. And we're good there, I think. This one, however, I believe has to be a do with the while down here. I could be totally wrong on that. But let's just run it and find out. I mean, that's half the fun of doing test-driven development, is just seeing what you can break. I broke another test, line 129, handle strings. I broke this. I was off by 1, looks like. And that would be, okay, line 117 is here, and that's a dot dot. I'm aborting a little bit too early, so I'm in this case here. Yeah, how do we do that? How do we do it? We want to go through it one time. So, okay, I think it's more like something like this. Bool matches end equals false. Maybe something. Matches end is this. While not matches end. We'll see. We'll see. I don't know. In my head, that made a little bit of sense. It did work. Great. Okay, so we have one failing spec, but that's on the 2A method, so we're not there yet. We're not there yet. We're essentially going to copy this logic right up here to the 2A, and it's going to be redundant, but I don't care. I'm going to trust the test to catch anything that I break. I know having two sets of code that do the same thing is unfortunate. But yeah, this is just going to be a quick fix and we're going to move on. So I did want to handle, I had this to do item. I did want to handle like, what if this is backwards? Z and A, this should just be an empty array. Also, what if this is AA, this should be A. And then we want to do all of this with 3 dots. That should be an empty array, and that should be an empty array, I think. So let's run it through Ruby and make sure. Yes, and let's run it through Natalie and make sure it breaks. Pretty sure it will. We're in an infinite loop, just as I suspected. So our special case here is if, I'll say, oh goodness, if the item is greater than or equal to, no, not item. If m begin is greater than or equal to m end, we don't need these null putters. Why do I even have those? I do need it there though, because that's a macro. Yeah, I need it on the macros, that's fine. So if it's greater than the end, then just return early. So we should just have one failing test now, if I did that right. And that's on 2A. So now, oh no, we have 2 failing tests. Line 133 did not work. So it's an empty string. I guess that's just greater than. We don't need the equal. Now do we have one failing? We do. Going to add everything to the index. We're doing good. So let's just copy this. Wait, why do I have item here? Oh, that makes sense. Yeah, I do have that. Okay. So let's copy this to here. And instead of that, we're going to do array push. And I keep saying it doesn't bother me that that's redundant. That's duplicated code. It does kind of bother me. Question is, how much does it bother me? All the tests are passing though, so that's pretty cool. We have fixed the bug. If I run Ben Natalie with WAT, or my original test case, it does A through Z, just as we expected. Well, now that we have green passing tests, all the tests are passing, just to make sure. I didn't break anything with string test, right? I don't think I touched anything that would affect that. Just want to make sure. Is there an easy way to share this logic with this? I could potentially pass a lambda. I could have an each function that takes a lambda. And the problem with that is that this nat run block is a fancy macro that does some interesting things. So let's go ahead and commit what we have. I can remove WAT. Fix ranges of strings. Fix string range bug. Z was producing a through, I think it was YZ or something. Ugh. Now just because I want to do the thing properly, was it went to YZ. Yeah. So we committed that. Is there a way, now that we've got these passing tests, is there a way to eliminate some of this duplication? What if we made an each that was sort of internal? That could be private. And it would take a lambda or a stood function. Takes a value putter. Something like that. I'll need functional. It's not even that much duplication, and it's right next to each other. I think I'm talking myself out of it. So I'm just going to remove that and remove that. And yeah, I'm still happy with the fix. I feel like that's pretty good. Let's run the whole test suite. Okay, all the tests passed. That's great. Well, thanks for hanging out with me. I hope you like my new setup. I moved my office around a little bit and got my recording setup kind of a little bit better. I'm going to keep working on it and hopefully work on some more videos pretty soon. I just threw this one together last minute because I thought this would be a fun bug to look at. And I hope you learned something. I know I did. I learned that Ruby's triple equals comparison is not what I expected. So yeah, good to know. I'm gonna look at that some more because now I'm concerned. Well, let's just look. A through Z include ZA is false, whereas this is, oh, it wasn't ZA, it was AA. That's right. So, okay, those do behave differently. That is not what I expected. I thought this was the same as include. How do we implement include? Do I need a test for that? Bin Natalie. So does this same thing work the same way? No, it does not, because I aliased include to triple equals. I'm sure I did. Absolutely sure I did include. I don't even have a test for include. Well, we're going to implement that really fast. You know, I've got time. We're going to make it work. So in binding gen, we have range include right here. Yeah, needs to be include. Okay, range include should just use the include method that we're going to make. And we'll do range value header include, and we'll make a test for this. I'm just gonna do this right now. Returns true if the given string is in the range. Should equals false, and this is not equal. This should be dot include. Something like that. Let's just make sure it passes with Ruby, make sure it fails with Natalie. Undefined reference. Yeah, that's right. We're just going to return false value the. False should be equal to true. 194. 194 is here. Okay, so we're going to kind of cheat. We're going to say auto array is this to a env. We're going to say return array dot send Is it that simple? That's the question. It is that simple. This is a little bit of a cheat. I think this could be optimized, but hey, we fixed another bug. Include, fix range, include. For strings, because it's strings that are affected. Ah, feels good. Okay, lots of bugs fixed. Fixed at least 3 bugs, I believe, all around ranges and strings. Thanks for hanging out. I'm really signing off this time. I hope you learned something, and hope to see you in the next video. Bye.